So this video is for slowing down in the positive direction.
Oh, replay. Okay, and then basically, based off that video, we were able to get this position time graph in the top. But as you can see, it has a curve, and it slowly, the slope of it kind of levels out at top, and it becomes 0. But basically, because it's a curve and we're trying to get the equation of it, we had to linearize it. So we got this second graph, which is basically position squared, like we graphed position squared versus time, so that we would make it a line. And this gave us, what do you mean? Okay, and we did that because the square of y is proportional to x. And then after graphing this, we found that the formula, based using the slope and the intercept, is position squared equals 599 inches squared over seconds times time plus 41.5 inches squared. And if you look at that equation, basically everything is inches squared, and like for the slope, when it's the slope times time, the seconds cancel out, so you're left with everything in terms of inches squared, which, because everything is in terms of inches squared, it's also, when you square root it, and then everything is just inches, so it makes sense.
Okay, and then we went to our velocity graph, and we know it's going to approach 0 because it's slowing down to a complete stop. So it's going to have a negative slope because it's going from moving to slowing down to 0. So that's why we have the slope is negative 27.297, so around negative 30 inches over second squared. And then that's the acceleration of this object, and we know our initial velocity, which is the vertical intercept, is 54 inches over seconds. So we made our formula velocity equals negative 30 inches over seconds squared times time plus 54 inches over seconds. So once again, the 54 is our initial velocity because at time 0, that's what our velocity equals. And what the object is saying is that every second the velocity changes in the negative direction 30 inches over seconds. Okay, so now to find displacement, we're going to highlight the velocity graph and take the integral, or the area under the curve, and we get about 38 inches, because the seconds times inches over seconds, the seconds cancel out and you just get inches. So the displacement of the position time graph, or the change in position for the object, is about 38 inches.
Okay, so that means that from 41.5 inches squared, or just inches, if everything cancels out, that the object has moved that much. And then, in addition, before when I was talking about the position formula, similarly, the slope, like what 41.5 inches squared means, is that when time was equal to 0, that's the initial position that our fan cart had. And also, when its slope is 599 inches squared per second, for every second, the position is increasing 599 inches squared. And because if you think of it like everything's in terms of inches squared, it's kind of like increasing at just 599 inches. And then also, based off the position time graph, we know that it's changing because it's not constant. So basically what that means is that the fan cart isn't moving at like the same rate the entire time. The velocity is changing and it's slowing down. So the position graph is, the top of it is leveling out and it's getting closer to 0 because the fan cart is starting to stop.
The slopes are getting closer to 0.
Yeah.